This is a 6Sigma digital twin. Digital twin is your data center that has been replicated in a virtual world. It contains vendor and model-specific representations of every power, cooling, IT, and infrastructural component. It represents the data center at application-specific levels of granularity. This digital twin was built to the highest level of granularity, where every physical object is represented explicitly. On the surface, digital twin looks like a DSIM tool. However, digital twin is different because not only does it look like its physical counterpart, but it also behaves like it. Digital twin is a physics-based simulation of your data center. Each component behaves and interacts with its surroundings as they would in the real world. And within digital twin, their behaviors combine to determine the data center's behavior overall. But before going further, let's back up to discuss the data center management challenge that digital twin addresses. Data center operations must meet business objectives consistently over the entire data center lifespan. This is no small challenge. These objectives not only conflict with each other, but are made more challenging by the fact that data centers can perform to their full potential for only one configuration: the design configuration. But over their lifespans, data centers will be configured in hundreds, if not thousands, of different ways, without ever coming close to their design configuration. In other words, data centers never reach their full performance potential and always fall short of a full return on investment. The only question is, how large will the shortfalls be? And the numbers reflect this reality. The 451 Global Digital Infrastructure Alliance found that the average enterprise data center uses only 56% of its capacity potential. According to the Uptime Institute, 34% of data center operators experienced a severe outage or service degradation last year. Also, according to the Uptime Institute, average rack density will continue to increase, making these problems worse in the future. And finally, the Uptime Institute found that service delivery speed and flexibility are critical to operators. So what are the causes of these dismal performance numbers? Let's zoom into a typical change request to see the problem in more detail. This change request will add 3 high-density IT racks to this data center. The resource requirements are almost double what the data center was designed to support. Can this request be accommodated? If so, what configuration will minimize costs and risk? Today, this change request would be processed by management guidelines that are based on the design requirements. But the requirements have changed. Will the old guidelines still apply? This configuration is a likely outcome of the original guidelines. Although, if one wanted to avoid potential service outages, this configuration might be considered. Or, if one wanted to aggressively conserve capacity, perhaps this one. But here's the problem. Today's tools and techniques do not help data center managers determine which option is best. It's guesswork from here. Today, the data center operation runs under a cloud of uncertainty that leads to service delivery delays, environmental risk, and inefficient use of data center capacity. This is where digital twin comes in. Digital twin offers a new approach to data center management that is based on simulation and the ability to predict and visualize the impact of change requests on data center performance, all while speeding up the management process with live connections to workflow and monitoring systems. Let's return to the example and use Digital Twin to process this change request. After simulating, Digital Twin reveals something that we didn't know before. The likely configuration will fail temperature compliance by overheating IT racks in the adjacent aisle. Digital Twin's ability to mimic behavior helps us to avoid an IT service outage. It also reveals the cause of the problem and provides the foresight needed to design a solution. A new cooling unit will get rid of this violation, but at a cost that is much higher than planned after accounting for the new cooling unit. Digital Twin predicts that the conservative option will meet compliance without having to upgrade the infrastructure. But this option is costly in terms of capacity utilization. Finally, Digital Twin predicts that the aggressive option will also meet compliance without having to upgrade the infrastructure. This is an unexpected result because gut feel and guidelines lead one to believe that 10 kilowatt racks cannot be placed this close to each other without overheating. To summarize, all three options can meet operating requirements under both normal and failure modes of operation. However, the aggressive option is by far the most cost-effective. With Digital Twin, this option can be selected with confidence, while saving capacity for use in the future. This example illustrates the impact of Digital Twin on a single change request. But imagine the cumulative impact over hundreds of change requests that a data center will experience over its lifespan. To sum up, Digital Twin represents a new approach to data center management that is based on the ability to foresee and quantify the performance impact of physical changes, while simplifying data center management by consolidating data and decision points across and through the data center operation. Thank you for watching this presentation. For more information about Digital Twin, please visit futurefacilities.com.